My name is Ong Shiyun, and in this video, I will demonstrate how to install and use the Crystal disk mark to perform the required benchmark for workload A and workload B. I will also explain how to obtain required computer organizations and architecture performs metrics and discard the benchmarks result. Before running the benchmark, I downloaded the Crystal disk mark from this official website, and after download was complete, I ran the installer and followed the before installation setting. The installation process was simple and only took a few minutes. So once the installations were completed, I launched the Crystal DeepMark from the Windows Start menu. No additional configurations was required, so the software was ready to use immediately. Crystal DeepMark is a storage benchmarking tool used to measure the read and write performance of storage devices such as SSD and HDD. For this process, I used the versions of Crystal DeepMark 9.0.1x64. So the software performs both sequencers and random read or write tests. The benchmark results are displayed in megabytes per second or MB per S, and input or output operations per second or IOPS. These values are used to evaluate storage performance based on the required COA performance metrics. You can see that this is the screen with the green icon. So this is the main interface of the Crystal disk mark. So in here, we can select the number of test run, test site, storage drive, and the benchmark type. So before starting the benchmark. Now I will demonstrate the workload A. According to the project requirement, workload A uses the random 4KIB read and write benchmark, also known as the RND 4KQ32T1. So we have to make sure that the type RND block site 4KIB, the Q's is the 32 and the trig is a 1, which is the Q equals to 32 and the T equals to 1. So enter OK. So this benchmark is simulate random access to many small files, which is similar to opening applications and multitasking. So I can select the RND 4K Q32T1 benchmark and just click it. So it takes for a few minutes to run. So after the benchmark finishes, the Crystal disk mark display the read speed, the write speed, and the IOPS value. So it is this. So, and now I will explain how to obtain the required COA performance metrics from this benchmark result. So for the workload A, the required COA metrics are memory bus control overhead, and also the DMA versus interrupt input-output handling. The read and write throughput shows here in megabyte per second are used to evaluate the memory bus controller overhead. Higher throughput indicate more efficient data transfer between the storage device and the system memory. The IOPS value indicate how many input and output operations the storage device can perform every second. So for the higher IOPS means better random storage performance. Modern SSD also use direct memory access or DMA, which transfer data directly between the storage and the memory, with less CPU involvement compared with interrupt-driven input-output. So next, I will demonstrate for the workload B. According to the project requirements, workload B uses the sequential 64 KIB read and write benchmark, also known as the SEQ64 Q1 T1. So this benchmark measures continuous data transfer and is commonly used to evaluate large file transfer. So in this part, make sure the type is SEQ, block size is 64 KIB, the Q is a T, and the trig is the Q is a 1 and the trig is a 1, which is the Q equals to 1 and T equals to 1. So enter OK. So this change with megabyte per second. Okay, so we can So I select the SEQ64KQ1T1 benchmark and run it. So it's also take a few seconds, a few minutes. So after the benchmark is completed, the crystal diskmark display the sequential read and write speed in megabyte a second. So now I explain how to obtain the required COA performance metric for workload B. For workload B, the required metrics are non-burst system bus latency and the cache line field buffering control limits. The sequential read and write throughput shows here are measured in megabyte per second. So the higher throughput generally indicate lower system bus latency because the data is transferred more efficiently. Sequential access also improve cache line field buffering since continuous block are data and can be data can be transferred more efficiently than random data access. These benchmark results are therefore used to evaluate the required COA performance metrics. And now I will discuss for the benchmark result. For the workload A, the benchmark measures random read and write performance. Random access usually produces slower throughput because the storage device needs to access data from different locations. However, this workload reflects common daily computer activities such as opening applications and multitasking. For workload B, the benchmark measured sequential read and write performance. Sequential access usually achieve higher read and write speeds because the data is transferred continuously. This improves transfer efficiency and reduce storage overhead. Overall, workload A evaluate random input I/O output performance, while workload B evaluate sequential data transfer performance. So in the conclusions, Crystal Diskmark is an effective benchmarking tool for measuring storage performance. Thank you.